guys. My name is Desmond, and I welcome you to our lesson for today, where we will be looking at mathematics. So, ladies and gentlemen, as always, please do allow me to say it is very much important that I say it is very, very much important because what I'm about to say, it's massively massive. Bantu Bakiti, massively important, ladies and gentlemen, that I say a day without learning something new, it's a day wasted. No, please do make sure that by the end of each and every lesson that I conduct, you learn something new. Very, very much important, ladies and gentlemen, over there. So, obviously, as I've indicated, today we'll be looking at trigonometry. So, you cannot afford to miss this lesson because this is an introduction where I take you through everything that you need to know, everything that you need to be aware of as far as introduction to trigonometry is concerned. So let's see, what exactly are we studying under trigonometry? So this word trigonometry, it's actually a Greek word where we actually study the relationship between sides and angles. So that means we are actually looking at only two simple things: the sides and the angles involved. But most importantly, trigonometry means triangle measure in English. Triangle measure. So that means the type of a shape that we are looking at is a triangle and not just any other shape. So this is a triangle. This is a triangle. This is a triangle. How do we know it's a triangle? Because it has 1, 2, 3 sides. 1, 2, 3 sides. 1, 2, 3 sides. That is what we call a triangle. Most importantly, it has angle, angle, angle. How many angles? 3 angles. 1, 2, 3. 3 angles. 1, 2, 3. 3 angles. So that means what makes up a triangle? It's actually 3 sides and 3 angles. So we are actually studying the relationship between the sides and the angles, of which the sides are 3, angles are 3. And most importantly, let's say this is angle number 1, this is angle number 2, this is angle number 3. So the sum of interior angles of a triangle equals 180 degrees, meaning angle 1, when you plus it with angle number 2 and you plus it with angle number 3, they must give you a total of 180 degrees. So that means if this angle, for example, it's 60 and then this one is 30, I'm just giving an example. So that means you're having 60 plus 30 plus this unknown angle, of which when you add all of them, they should give you 100. So that means you can take this to the other side, that to the other side, then you will know what is the unknown angle. These are the basics that you should be aware of. But listen to this. Under trigonometry, we are not looking at any triangle, but we are looking at this special triangle, which is referred to as a right-angled triangle. What is a right-angled triangle? The only way you can know, it's in two ways. The first way, that's if you see that 90-degree sign there. The second way, they can still give you a triangle similar to that, and they don't draw that. So, but in the statement, they will say maybe given triangle ABC, and they say it's a right-angled triangle. So that means it's two ways. You can be told in the statement, or you can see by that 90-degree sign. So under trigonometry, we are looking at this type of a triangle called a right-angled triangle. Very, very much important, ladies and gentlemen, over there. So most importantly, now that you guys are in grade 11, things are now accelerating. So I'm telling you guys, out of today's lesson, you will most definitely learn something new, even though everything that I'm going to be talking about, it's not new. But one thing for sure, you will have a better understanding of what you knew, but you probably did not fully understand. Most importantly, I have to emphasize this point to say, when we are looking at a right-angled triangle, that's when you are allowed to use this trig ratio called cos, sine, or tan. And lastly, theorem of Pythagoras. Please be aware that you can only use this, that, and this when you are dealing with a right-angled triangle. Someone is wondering, what if we are not having a right-angled triangle? That means you don't use these things. That's where you use the sine or the cosine rule, which is what I'm going to teach you guys at a later stage. But if you are just having a triangle similar to that, can you see? It is a triangle, but it is not a right-angled triangle. So you can't use those things. That's where you need to use the sine or the cosine rule, because it could be an isosceles or scalene. It's not a right-angled triangle. But under trigonometry, in today's lesson, we will be looking at anything that has to do with a right-angled triangle. But remember, guys, 3 sides, 3 angles. Just to keep it simple, let's name those sides of a right-angled triangle. Maybe let me draw something similar to that and say we are having a 90-degree angle there. Then we know we are dealing with right-angled triangle. So this is a side, this is a side, this is a side. All these 3 sides have specific names. And those names, we've got hypotenuse, you know, we've got opposite, you know, we've got adjacent, you know. So always hypotenuse, it's easy to identify. Let's say we are having triangle A, B, and C. So obviously the side which is opposite to that corner there of the 90-degree thing, that one, which is the longest side, is what we call a hypotenuse. So this is where it gets interesting. Here comes a question. Which side is then opposite, and which side is adjacent? Is AC opposite or adjacent? Is BC opposite or adjacent? Remember, mention your name and I will recognize you, honorable member. Don't unmute and give an answer, but mention your name and I will recognize you. Anyone who would like to tell which side is which. Remember, in case if you've got no idea, unmute and say no idea so that I will explain, and that's how I know if you got my question. Akanya lindiwe yandiswa aphelele bosisiwe mzozozo K-more. Honorable member, I see we've got Jeremiah 29 verse 11. I just couldn't get your name, honorable member, but are you guys still there? Are we still together? Did you get the question?
Bosisiwe.
Bosisiwe, okay, go for it, honorable member.
I think we need a reference angle in order to identify which side it is.
100%. So that means at this stage we can't tell whether this is adjacent or this is adjacent. But if I do that, then which side is which position? I'm giving you that angle. So it obviously means the side which is opposite to that reference angle, it is what we call opposite. Then this one becomes adjacent. But if we now change that angle and we change it from there and we put it there, also these sides change, because now this is the side which is opposite to the angle. That is why it is going to be angle, and this one, it is the obvious side being adjacent. So I'm just going to remove all of this very quickly. But let me also have those names to say we've got hypotenuse, we've got adjacent, we've got opposite. I just want you guys to notice something. So remember, guys, now we represent all this information on a Cartesian plane. What is a Cartesian plane? It has the horizontal and the vertical axis. This is the x-axis and this is the y-axis. And remember, our angles starts from there being 0. And then obviously there we have 90 degrees, we have 180 degrees, we have 270 degrees, and then lastly, we have 360 degrees. So this is what we call cast diagram. So the cast diagram, this is how you write it. C, A, S, and then T. So cast diagram. Okay, so now let's see. We have what we call the terminal side, well known as the radius, starting from the origin. Let's maybe start it from the first quadrant. So this line that I drew is called a terminal side, but don't worry about that name being called terminal side. Just remember that this is your hypotenuse. When it's on the cast diagram, you don't need to call it hypotenuse, but we call it the radius. So that is why there I'm going to write R. So in brackets, let's just remember that a hypotenuse on the cast diagram is our R. But remember, we are studying a right-angled triangle on a Cartesian plane or on a cast diagram. So that means from this line, we need to form a right-angled triangle having a 90-degree angle there. So this is where you are having your angle. So can you see at all the times, Bantu Bagiti, your vertical line, it is that vertical line which will always be y. And then this side, it is the one which is positive x, because on this side from the origin, you have positive x values, positive y values above the origin. So I can now make a conclusion to say this side being adjacent, it will always be represented by letter X, and then the opposite will always be represented by Y. It doesn't matter whether your right-angled triangle is in the first quadrant or the second quadrant. In the second quadrant, this is how it looks like. You have negative X, that is the only difference, but your Y is positive because you still have your right-angled triangle above the origin. So it doesn't matter whether it is in this quadrant. So can you see we are nicely forming a butterfly there? So obviously what changes is that Y, because below it's on the negative side. But most importantly, your R at all the times is always positive. It's always positive. Maybe let's see how it looks like in the fourth quadrant. So we are having something similar. So can you see that means you are going to have a negative y value, but in terms of the x, it's a positive x value because of the quadrant in which that right-angled triangle is. So it doesn't matter whether you call this a quadrant number 1, then that means this is going to be quadrant number 2, this is going to be quadrant number 3, and then this is your quadrant number 4. Most importantly, you need to remember that all the angles that lies between 0 and 90, we call those angles acute angles. Always remember this. And then all the angles in the second quadrant, what are those? It's obtuse. Yes, it's obtuse angles. I think here we are having a reflex angles. And then in the fourth quadrant, I think we are having a revolution. Yes, revolution. So, can you see your butterfly is nicely completed there? So it's either you take a screenshot of this, or otherwise, you know this is being recorded and you can catch up at a later stage. You might not need to write the notes because this is being recorded. So that's all that I wanted you guys to be aware of regarding a right angled triangle on a Cartesian plane or on your cast diagram. I'm just not sure if you guys remember that the purpose of us writing this as cast diagram is because as we go deeper, you will realize that this C, it actually refers to cos, which means in the fourth quadrant, it's only cos which is positive. You will understand later. This T, it stands for tan, which means in the third quadrant, tan ratio, that tan, it is positive. You will notice later why. In the second quadrant, it is actually S for sine, which means in the second quadrant, sine is always positive. I'm telling you guys, going forward, you will need to remember all of this. This actually summarizes what your teacher is going to teach you at school. It might be different information coming differently, but it all comes down to this summary. So just always remember to interpret this. I'm pretty much sure that it's well explained and you guys can easily understand it. So we are now about to move to unit number 2. But before I do that, I just want to quickly confirm. Anyone who's got a question in relation to that, or did that make sense to everyone? Any questions, or did you understand what was explained?
No question.
No question. Okay. In that case, I will then have to remove all of this. Remember, this lesson is being recorded. These notes that I'm using to present this lesson are posted in the library. So let's quickly move on to unit number 2. Luckily, in unit number 1, I've covered some of the upcoming units, which we are just going to skip, and I will let you know when we get to that point. But for now, I want you guys to remember something. So I just explained to say this is what we call a triangle. But here comes the question. Is this a right-angled triangle? Yes or no? And how do you know?
It's a triangle.
It is a triangle 100%, meaning it is not a right-angled triangle because we don't have a sign and we were not told. 100% on the. So now, the moment I start doing that, then it is a right-angled triangle. So now I need to know which side is which. So this side, obviously, we know it is the one which is hypotenuse. But now, which one is adjacent and which one is opposite? You cannot tell until you are given the reference angle. Maybe let's say the reference angle is there. So now you know that, okay, this is now opposite. how do you know it's opposite? Because it's opposite to the reference angle. And then this one, it's an obvious side being adjacent. So remember, guys, we said opposite represented by Y, and then this one represented by R, this one represented by X. So just remember that, so that as we go deep, you understand where the X, Y, and R come from. So if you remember, we discussed the three trigonometric ratios. Maybe let me write it there to say trigonometric ratios. But most importantly, guys, let me take this opportunity to remind you guys that when we talk about the ratio, we talk about something over something. It doesn't matter whether you write it as a 1:4. It's a ratio. Whether you say 2 out of 100, this is a ratio written in three different forms. So under trigonometry, we have what we call trigonometric ratios or trig ratios. What are those? We talk about the sine, the cos, or tan. These three things are the three trigonometric ratios that we talk about. So remember, it has a word being ratio. So that means cos, it's actually going to be something over something. So that means even sine, because it's a trigonometric ratio, it has to be something over something. Similarly with tan, because it is a trigonometric ratio, it has to be something over something. This is where you now remember what is it? Let me maybe write it down. So car. I think it's so, then it's car, towa. Yes, I think this is how it's summarized. Soccer tour. So that means this is what you need for S for sine. This is what you need C for cos, and then T for tan. So let's see. That means for sine, it's actually for opposite over H for hypotenuse. So that means sine, its ratio is opposite over H for hypotenuse. Let's see. For cos, it's A for adjacent over H for hypotenuse. And then let's go to tan, meaning O for opposite, and then A for adjacent. So these are the trig ratios now represented in their names. Okay, very quickly, let's talk about them in a form of X, Y, and R. So obviously adjacent, we said it's X over R being H. So for sine, it's going to be Y over R. That means for tan, it's going to be opposite over opposite. What is it? It's Y adjacent over X. Yes, 100%. So I hope you guys can easily notice the ratios. But hey, there's something called reciprocals, the cousins of trigonometric ratios. The reciprocals, Bantu Bagiti, maybe let me write it down. Reciprocals. What are the reciprocals? This is where we talk about sec, we talk about cot, we talk about cosec. I'm just not sure if you guys did this in grade 10, but I don't think so. You might be hearing these three for the first time. So that means these three are actually the cousins of those. So whose cousin is, let's see, is it a question coming through?
No, see, I was saying we did this.
In grade 10?
Yes, sir.
Okay, 100%. So that means up to this point, nothing is new. So let's try to merge the cousins. So honorable member from the past years by the name of LB said, you focus on letter number 3. No, not that one. letter number 3. It's going to tell you which cousin is. So can you see? C stands for cos. So that means um, the cousin for sec is a cos. Most importantly, what is the difference between cos and sec? The only difference is that you take this, you write it at the top. So that means sec is actually r over x. Let's see, who is the cousin for sine? Letter number 3, 1, 2, 3. That S means sine. So that means cosec is the cousin for sine. What is the difference? You just swap this at the top and then that at the bottom. Let's see, what about tan? 1, 2, 3, T for tan. So that means the cousin for cot is tan. So I haven't caught there. What is the difference? You just take these, you write it at the top, you write it at the bottom. So Moleboge, this is a very good indication that the information does not change. What you learn in grade 12 is what you learn in grade 11. I can still perform the same presentation to grade 10s because the information does not change. It is the same. But what changes is the manner in which questions are asked. So that's how you are able to distinguish the difference. But the information is hey, Bantu Bakiti, it's more like having a potato. The potato does not change. What changes is what you do with the potato. One can do those chips that you put in the quarters, and then one can do those zimbas. Hey, you can even do mashmos with the same potato. What else can you do with a potato? It's a lot, Bantu Bagiti. It's a lot. It's unfortunate you can't do pass with a potato. So that means you need to study. It's a lot, but you can't. What else? I'm just trying to think what else you can do with a potato. You can, what do we call this thing? Wedge. You can even do ama wedges, Bantu Bagiti. It's a lot. So that's what I mean, Nomvula, when I say the information remains the same. What changes is what you can do with that information. So the information is the same, but questions will be asked differently, which is where now the tutor comes in. Say, when a question is being asked in this manner, you need to remember this kind of information, then you will easily understand when the information is being explained. Here comes a question. Did that make sense to everyone, or is there someone who's got a question?
Makes sense.
No question. Last one to confirm.
It's clear, sir.
100%.
No questions.
Remember, guys, this is just us doing an introduction. I'm praying that you guys fully understand everything in today's lesson, but at the same time, it may look easy, but one thing for sure, there will be something most probably new that you're going to learn out of this lesson. It's not only about you learning, but having a better understanding. So let's quickly jump on to unit number 3. What are we going to be talking about? Hey, we talk about these special things, guys. Special angles. I don't think, did you do those in grade 10? I don't think so. But if you did, then you did, ne?
Yes, sir.
Did you? Okay, 100%. So let's quickly do a revision on those. I'm sure you remember. It's 30 degrees, 45 degrees, and I don't know if you'd like for me to call that 60 or 60, but whatever that it is, we know that we are referring to that number. So let's see. Let's start with maybe the one for 45. You will notice why I want to start with that one. So at all the times we know that special angle for that one of 45, you'll always have 1 1 there, provided that 45 whether it is there or it is there doesn't really matter that much. That is why you have one there. Whether the angle is there or is there, these two angles are equal. That is why you are having equal sides. And when you use theorem of Pythagoras to calculate that, you end up having square root of 2, because you're going to say x squared plus y squared is equals to r squared. And 1 plus 1, obviously that it gives you 1. So you end up having a, what is it? That. And then, no, this is 2. 1 plus that is 2. Then you square both sides. And then that's how you end up having your r being a square root of 2 there. So it is the same principle. That's how so okay, so let's quickly jump onto that one of a 30. You still have a right angled triangle. Angle 30, it's up there. So they say with you having an angle there, your opposite, it's going to be 1, and this will always be square root of 3. And then if you use theorem of Pythagoras again, you will end up having 2 there. Maybe let's check. Square root of 3, you squared, plus 1, you squared, you have r squared. So obviously this removes that, and then you end up having 3 there, that you plus it with 1, which is equal. So this plus that is 4, which is equal. So that means when you square both sides, this is actually 2, which is, yes, can you see? So that is where that 2 is coming from. So very quickly, let's do the last one where we are having a 60 or 60 being there. I'm telling you guys, they say whether you have 30 on that one being there and you have 60 there, you will still have your square root of 3 being on this side. And then you will have your own being this one being that. So obviously we know if we have those, our R is always going to be 2. So this one, easy to remember. So sometimes this one can be explained as a combined drawing where they do this. And the reason to that, it's simply because there are too many common things there. You have 1 being there. You have square root of 3 being on this side. You have 2 there. So that means that's when your 30 degree is there. And then you still have your 60 being there. So that is why sometimes they might not teach you in that way, but just teach you this one. But remember, it's only correct when it has that 90 degree, because we know 90 plus that, it adds up to 180 degrees, which is the sum of interior angles of a triangle. So I think with regards to the special angles, all that I've explained makes sense, and I'm well aware that you guys still remember all of those. I'm not sure. Any question before I quickly move on to unit number 4?
No, sir.
No question. Okay, 100%. I also did not expect a question on that one. So remember, guys, it might be boring to some of you, but I'm telling you, when it gets difficult, we will need this boring lesson. Okay, let's quickly see. Unit number 4, it's named using your calculator. So that means this is where I'm assuming that you guys are using calculator. So I'm just assuming that you haven't used your calculator using trigonometric ratio. So let's say, for example, we are given a triangle similar to that. Maybe let's say this is P, this is Q, and let's call that R. And examiner says find angle P and angle R. But most importantly, they give you this side to say it's 4 meter, and then this one is 12 meters. So now, anyone who would like to suggest how are we going to find a P? But maybe let me say, what tools do we have in order to solve questions related to this type of a triangle, what tools do we have? That is my first question. What do we use, or what can we use? Are there any formulas, or what is it that we can use to solve questions related to that type of a triangle? Silence in court. Okay, maybe let me answer this one and continue to explain. Only if it doesn't make sense, let me know. So, every time when you have a right-angled triangle, the tools that you have, it's cos, sine, tan, and theorem of Pyth. When I talk about the tools, these are the 4 tools that you have to answer questions related to that. So now they want you to calculate a angle P. Again, who would like to suggest how can we possibly find that angle P? Maybe let's call it angle theta, even though we know it's angle P. How are we going to find that angle? Maybe let me do this. Anyone who would like to give it a try?
To theorem of Pythagoras.
Theorem of Pythagoras. So the formula is r squared equals to x squared plus y squared. Matapelo, you did well by saying that, because you are definitely going to learn something there. So as part of your notes, Matapelo, just say we use this one, the theorem of Pythagoras, only if we know 2 sides. And then you can also say 2 sides, no angles involved. No angles. So I'm not sure, Matapelo, if you understand what I'm trying to explain there. So it's more like, always remember a theorem of Pythagoras only if you know 2 sides. For example, you know this side and you know that side. That means you use it to calculate a side number 3. And also, if they don't talk about angles, that's when you remember theorem of Pythagoras. But only if they are talking about angles, that's when you remember cos, sine, and tan. Because 1, 2, 3, they have angle. You have a cos of angle, sine of angle, and tan of angle. So it's more like you only use this if you have 1 side and 1 angle. Then that's when you can use the trig ratios. But 2 sides, no angles, theorem of Pythagoras. Did this help, Matapelo? Do you understand why we won't use theorem of Pythagoras?
Yes, thanks.
Okay, so anyone who would like to guess, how are we going to find angle P?
Say we can use sine theta and say opposite over hypotenuse, which is 4/12, and get the answer.
Opposite over hypotenuse. Yeah, I think you are onto something, because we need that trigonometric ratio that has opposite and also hypotenuse. That's how you choose. So you ask yourself, between these 3 trig ratios, which one has a opposite and a hypotenuse? That's when you can just write that so katuwa. Then you check which one has hypotenuse and opposite. It is the sign. So that is how you choose. So can you see? That means you're going to say sine of angle P is equal to opposite is what? It's 4 over hypotenuse is 12. So that means your angle P, this is where you do the arc sine or second function of that, and then you get an answer. So that's how you get your angle there. And that angle is what? I think it's 19.47 there. So did this make sense to everyone? Or there's anyone who's got a question? Okay, so next question, they say calculate angle R. You can either use suitable trig ratio, or you can just say, since I know that angle Q it's 90 degrees, I can plus it with this angle that I calculated and then plus it with angle R. I know they must give me 180. So that means you have 90 degrees that you can plus with 19.47 degrees plus angle R equals to 180. That means angle R is going to be, you take that to the other side, and then that's how you get your angle R. Otherwise, you can still use a trigonometric ratio that has adjacent and hypotenuse. So now can you see? So that means with examiner saying calculate angle P, they are simply saying calculate that angle having this as your reference angle. That's how you know which side is which. And again, when they say R, that means you need to forget about that one. And now your new reference angle is this one. Then you will know this is now your adjacent, that is your hypotenuse. Then you look for that has adjacent and hypotenuse, it is a cos. Then that means you can use cos to calculate that. And then if they said calculate this side, that's when you can use a theorem of Pythagoras. You can still use the trig ratios because you have a one side, you also calculated one angle. So anyone who's got a question on that before I quickly move on to the next part of this lesson? Anyone who's got a question, or did that make sense to everyone?
Question.
Yebo.
No, or remove PQ is opposite or QR is opposite cos. In other words, it's QR is adjacent and PQ is opposite. So why we use sine, not cos?
Okay, maybe let me quickly explain. But wait, Matapelo, o joine mohara lesson or o thomile mathomong?
Ke jenne gare ga lesson, ne ke busy.
Oh yes, that is why. So this is what I'm going to explain very quickly. But remember, to everyone, in case if you joined the lesson late, you might not fully understand everything. But let me quickly re-explain. So this is what happens, Matapel. You have a 90-degree angle there. Let's say this is A, this is B, this is C. This side, which is opposite to that 90-degree, is what we call hypotenuse. But from here, you can never tell whether this is adjacent or this is opposite, or this is adjacent or this is opposite. Why? Because you don't have what we call a reference angle. So now, let's talk Matapelo. If I put an angle there, which side is adjacent, which side is opposite? Remember?
AB. AB is adjacent.
Yes, you are 100% correct, meaning BC is opposite. So if I put that angle there, which side is which?
BC is a adjacent.
Yes, so can you see? It depends on where the angle is. It depends on where the angle is. Now, let's go back to your original question. I'm just wondering if I made a mistake because you seem to be knowing these things, Matapel. Let's quickly check. That's how I'm going to know if I made a mistake. You tell me, what was your question, Matapel, on this one?
Say, why are we using sine instead of cos? Cos we want PQ, not QR.
But remember, the question says find the angle and not the side. So the moment you start saying PQ, we now talk about the side and not the angle. So the question wants the angle. So you used the trigonometric ratios to calculate those angles. So I just added a question there to say if you want to calculate the side, you can use a theorem of Pythagoras because you have that and that. And again, you can use trigonometric ratios. You can either use cos or you can use sine. It all depends on the angle. So that means if you have that angle there, what is it? It's 19 point, let me quickly check. Is it 19.17? But okay, 19.47 degrees. So now let's talk Matapel. I'm just not sure if I'm understanding your question or if you are answered by what I've said. But if you want PQ, you can use sine, you can use can you use sine? Sine it cannot be used, but you can use cos because you have adjacent and hypotenuse. Then, if you use this angle, that's when you choose a suitable trig ratio. So, in short, what I mean is you can use anything. It depends on the angle that you are using, which is what we call the reference angle. Are you answered, Matapel? Do you now understand, or did I not answer your question?
Yeah, I understand, sir. Thanks.
Okay, 100%. So, very quickly, we will move on to, let's see, I think from here it's unit number 7 because unit number 5, unit number 6, it's actually covered from unit number 1 up until unit number 4. So that's how I shortened this lesson to be within an hour or about an hour long. So now that means we're going to jump on to unit 7. So can you guys see, very, very much important that you don't miss today's lesson. Imagine if you start attending tomorrow, you might get a bit lost because I won't repeat what I'm explaining in today's lesson because this is being recorded. So that is why it's very much important that you record in case if you missed any lesson. So now we talk about what is it? The graphs, but we call them the graphs of what is it? A graph of the trigonometric function. So let me just say we are now about to talk about trig functions. Trig functions. The moment you hear the word trig, you just need to remember sine, cos, and tan. So these are the functions that we are going to be sketching. I'll just be teaching you the basics. Maybe let's start with this one. Let's say maybe they say plot f of x, which is equals to, maybe let's keep it simple and say sine angle. And they normally say where x is the element, not x, but where angle is the element of, maybe they say negative 360 and they say positive 360. Where do you start plotting that? You focus on that given range. They're simply saying your angle, which is going to be along the x-axis, it has to start from the negative side up until the positive side, negative 360 to there. But we know we also have that y-axis. So this is where you say, obviously you know this is 0. So you're going to have a 90 in multiple of 90s, and then you are having a 90 degree, 180 degrees, 270 degrees. You are having a 360 degrees. So obviously on this side, you're going to have negative 90, negative 180, negative 27, negative that. So maybe let's say negative 90 degrees, negative 180 degrees, negative 270 degrees, negative 360 degrees. Remember, guys, I'm just giving you the basics of how you plot this type of functions, the trig functions. It's going to get deeper in the upcoming days, where I encourage all of you guys not to miss any of our upcoming lessons, because if you do, it's going to be a problem. And again, if you join lessons late, make sure that you catch up as soon as the lesson is done, so that you'll be on the same page as everyone. Okay, now that you have done this, guided by that, this is where you now plot, which is the easy part. You just vuga malamba, hey, olele malamba, ouchi, zboy. Okay, uvugile malambane. So you just say sine angle. Can you see that angle? You start from negative 360. So that means you're going to say negative 360. What is it? It gives you 0. Then you just put a dot where it says it's 0 on 300. So you go to the next one. It's negative 270. You get positive 1. So above that, you do that. Let's go to the next one. Negative 180, you get 0, you put a 0 there. Negative 90, just say negative 90, gives you the place 0 there. And then let's go to 0, it gives you a 0 there. Let's go to 90, can you see 90? It gives you 1 there. Let's go to 180, gives you 0. Let's go to 270, it gives you a negative 1 there. Let's go to 360, gives you 0. Now you are done. Just plot by connecting the dots. So can you see, these are the basics, Pantupakiti. It's very much important that you follow the standard procedure, because what you guys normally do, you just randomly do these things and not having a proper procedure. So that means you know that every time when you are given something similar to that and you have to plot it, you follow the standard procedure of doing that. That guides you from where to where. Can you see, this part is from the negative side and this part on the positive side. Maybe let's now say this is the function of f. And let's say on the same set of axes, let's also plot a g of x, which is that, where again that is the element of that negative 360 and positive 360 there. You still do the same. On that same set of axes, you are just going to say cos. You start with negative 360, it gives you 1. So can you see, above that, you put 1 there. You go there, you edit negative 270, it gives you 0. You put 0 there. You go there, it gives you negative 180, it gives you -1. I already see the trend. And then you go there, probably 0, yes, 0. And then you go to the next one, being 0, it gives you 1. Then you put it there, 90, positive 90, it gives you 0. And then now let's go to a positive 180, gives you -1. Plot there, 270 gives you 0. Let's see, 360, it gives you 1. Then you put a dot there. Can you see, Bantu Bagiti? You now connect the dots. So it does something similar to that. It does something similar to that. Just do it nicely without rushing, Bantu Bagiti, because you fully understand what you are doing there. So can you guys see? Then you're going to say, this is the graph of Brageorge. So you have done a sketch of those functions on the same set of axes. Here comes a question. Does it make sense what I've explained there? Did everyone understand what I've explained there?
Yes, sir.
Last one to confirm.
Understood, sir.
Yes, sir.
Okay, 100%. Let's see. Very quickly, we are going to move on to the tan function. Remember, when we go deeper, that's when we're going to be talking about the maximum, the minimum values, the range, the domains, the period, and what else. It's going to be a lot that we're going to discuss. But for now, just be aware that to plot the standard procedure, to plot, this is the standard procedure that you can always rely on and you will never go wrong. So let's see. Lastly, let's plot maybe this one and let's call it h of x. So h of x equals, let's keep it simple and say tan that, where that angle is the element of negative. Let's also do that, and let's do that over a full length. So that means you will still need your Cartesian plane. So this side has to be equal to that because you are having full 360 and 360. So obviously that means here you can have 90. What else are you having there? Let's see, it's 90, 180. Yeah, no, I realize I'm not having enough space there. Let me do that. And then we have that, yes. And then also there, maybe let's say there, 92, that. Yes, I think it's going to fit in nicely. So you obviously have 0, positive 90, that, 270, 360 there, negative 90 there, negative 180 there, negative 270 there, negative 360 there. Yes. Here it doesn't matter. You can have your -1, you can have your 1. As we go deeper, you will realize, why am I writing 1 there, and why next time it could not be 1 and be a different value. So let's see. So basically, for me to know that it's going to be 1, 1 there, is because there's that invisible 1 there, namely the amplitude. But over time, it will make perfect sense. So let's sketch. You still do the same. We're going to connect the dots. Tan -360. I'm getting 0. 0 there. Let's go to the next one. Negative 270. It gives me error. Where it gives you error, that's where you do this. Remember, these are your lines of asymptotes. So axis of, your asymptotes refers to where you get an error. So let's see, tan of negative 180, I'm getting 0. Let's go to that one, negative 90, again. Then that means everywhere you get error, you do that. You do that. Okay, let's maybe go to 0. 0 gives 0. Let's go to 90. It gives error. So that means where it gives error, this is what we are having. Let's go to 180. It gives 0. Let's go to 278. It gives us error. Then everywhere it gives you error, this is what you do. I hope you guys are also getting errors there. And I'm not the only one getting errors. 360, I'm getting a 0 there. Okay, so now let's see. It's going to be difficult to plot because we don't know whether from this point we go like that and then we go like that, or if we go like that and then from there we go like that. That's what is going to make it difficult. This is where you need what we call the critical points. What are the critical points? Critical points are those points in between your major values. You see, there. I will teach you at a later stage how you calculate those in the most simplest way, so that whether you are given something as y, let's say 2 tan of an angle, maybe they say plus 2 there, you will easily know how to find your critical values. Sometimes they can still say angle there and then plus 30 degrees there, they still say plus 2. Gets worse. So imagine you having to plot that, but you struggle with the basics. It's going to be difficult, Bantuba Kitty. That is why you can't afford to miss any of my upcoming lessons. So what is a value between 0 and 90? Okay, this is how you do it. You can just say 0 plus 90 divided by 2. 0 plus 90 divided by 2, obviously it gives you 45. So that means there it's actually 45. What about that? It's the midpoint, guys. This plus that you divided by 2 is going to give. So that means 90 plus 180, then you divide it by 2, 135. This one, that plus that divide by 2. 180 plus 270 divide by 2, you get 225. 225. 270 plus 360, 270 plus 360, you divide it by 2, it gives you 315. So you still have the same thing on this side, but with the negative values. Then here, negative 135, this side, negative 225 degrees. This one, obviously, negative 315 degrees. So why did we need these critical points? It's because we wanted to know, when you say tan, you start with that one, negative 315. What does it gives you 1? So can you see, that's how you shape your function. Then you know from that point, it's not going in this direction, but it's going closer towards that asymptote there. It must never touch, never cross. Why? Because it gives you error above that negative 270. Then let's go to the next critical point, being negative 225. You get -1. So that means you put a dot there. Let's go to that one there, because here we know it's 0, because that means this is what we are now having, but we need to know. So can you see already? You can tell this one, if you punch it, it's going to give you 1. So it's very easy to notice the trend for this type. So that means also when you put -45, it's going to give you 1. Then you now have that type of a shape which does that. And then hey, be careful, it must never touch. Once it touch, I'm telling you. So this one also still the same. It's going to give you a -1 there, and then it's going to give you 1 there. Then you just connect the dots. You just connect the dots, and then obviously this one is going to give you -1, and then it does that. Then that's when you can say this is the graph or the function of h. Then you are done. You score yourself 3 marks for doing that. Anyone who's got a question, or did that make sense to everyone? Jeremiah 29 verse 11. I'm sure this honorable member won't know that I'm calling their name. Jeremiah 29 verse 11. Are you there, honorable member? She won't know. I'm going to send her a WhatsApp. Okay, so this is today's quote so that your parents know that you have attended today's lesson. One can say Jeremiah, one can say 29, one can say verse, one can say 11. So you can comment Jeremiah 29 verse 11. Where did I get this? You know, you guys you like naming yourself differently. But in this case, it's actually a parent of the learner who had that. And when I saved their number, it was saved as Jeremiah 29, verse 11. I hope it's a very nice scripture there. So, ladies and gentlemen, did you guys get all that was explained? There is the code. Anyone who's got a question before I sign out? Or everything made sense? Bosisiyo, did you understand, honorable member? Nomvula, are you sure you understood all that was explained? Or did you also join late, honorable member? Luyanda, are you okay that side?
Yes,
Leslie them are Leslie's.
thank you.
I see Kamo is still there, and Kamo was the first to join. Kamo, are you okay that side, honorable member? Does everything make sense up to this point?
Yes, it does make sense.
Okay, 100%. So, ladies and gentlemen, I do thank you very much for joining. Remember the code. Um, hmm, I just remembered something. Okay, this is what you're going to do. I'm going to send a link in this group. It's going to be at BSTSA tutor. So this is the link that I'm going to send. You click on that link, it's going to open an inbox. Then you send me a list of the chapters that you guys have already done at your school. Our new tutor will be joining very soon. We will introduce the new tutor shortly. So the main aim is so that towards exams, you guys don't only rely on me to prepare you for exams, but if we have an additional support from another tutor, then we know I can focus on certain chapters, you focus on certain chapters, if possible or if necessary. During those times when you know you'll be writing maths, we only focus on maths and as much as possible, even if it means to do 2 times a day, let's say 2 times a day. Then we know you guys will be prepared, because it might be challenging in case if for some reason during examinations, if it happens that I have some agent matters to attend to, then you guys will be in big trouble. Okay, so just remember the code, and then I'm going to send this link. You click on that link. That's where you guys submit your tests. You're going to write tests, and that's where you communicate with the manager or tutor. So I mean admin. So guys, thanks very much for joining. My name is Desmond. And I'm out. Someone just joined, and now Sophie, you missed the lesson, honorable member. Just make sure to catch up.
Sir.